When you have a bunch of recorded videos or audio note and you want to transcribe them, there's not really a reliable tool out there that can transcribe them with high accuracy and high speed. In today's video, we're gonna make the fastest auto transcriber that you can run offline on your machine with no internet. Let's get into it. When you have an audio file, let's say it's 10 minutes. If you wanna process this directly into Whisper, which is a model that can transcribe your audio to text, if you wanna fit this 10 minutes audio file directly into Whisper, the challenge is Whisper try to understand every single second of the file and try to find the correct transcription for that. But your audio file might have some silence in it, some period of time with no talking. Let's say there's only talking here, some talking here, here, and here. So if you only have small period of talking in a 10 minutes audio file, the Whisper doesn't understand that and it will go through each second of a 10 minutes audio and it's gonna take forever. Especially if you have a lot of audio files and Whisper have to go through all of them, it would be pretty slow. If we can somehow detect these talking points and detect the silence part, and we can somehow edit that audio file before fitting it to Whisper, and we are only passing the part of the audio file that has a conversation or a human voice in it. So the first thing that we need to do is to detect which part of an audio file is talking point and which part of it is completely silent. And by doing that, we can ignore all the silence and only pass the talking points to the Whisper. It's going to make the Whisper much more faster and much more accurate, because one of the bugs in Whisper OpenAI is that when you have a long period of silence, sometimes it doesn't detect that silence and returns something completely irrelevant. So if we can delete all this silence, we're gonna make it more accurate and make it faster. For doing that, we can use a tool and pass each file to the ffmpeg first, and we're gonna get a bunch of talking segments, and we can only transcribe the talking segment. By doing that, we're gonna use the maximum power of Whisper AI and ignore all the silence. And the second thing we're gonna do, for each audio file, we're gonna run it in a separate thread or process. If we do that, we're gonna make sure each file has its own context, because this talking point might be relevant to this talking point. So we don't wanna mess them up together. We're gonna keep them separated, but at the same time, we wanna run each file separately in a new thread or a new process, okay? So we're gonna use ffmpeg to delete all the silence, and we're gonna run each file separately in a thread or process, okay? So that's the whole thing we're gonna do in this video. We already have this code from the previous video. I'm gonna link it up here so you can watch it, but I'm gonna create a file called fastpi. We already have this function that download the data from a link. We're gonna use that. If you remember, this was our link that download the audio file, actually stream it. Fantastic. Now, if we run this code, actually, we're gonna download audio in a streaming audio from this URL and put it right into this folder. Pretty simple and straightforward so far. Let's make the log a little bit better. We're gonna have split silence function that's going to get the audio bytes as input, which is basically bytes. Gonna import ffmpeg, and I'm gonna say dot input. So we're gonna read the audio, then we're gonna filter it. I'm gonna change this number to -10. We're gonna play with it because it really depends on the quality of the audio that we're working. So we're gonna play with it, but for now, I'm gonna keep it at -10, and the duration, I'm gonna keep it at 0.8. We're gonna play with these numbers to get it accurate. Then for the output, I'm gonna use pipe format binal, and we're gonna run it in an async way. All of that gonna be our reader. Let's see what's that pipe look like, what's the output look like, and we're gonna extract the beginning of the silence and the silent duration. We're gonna go through this folder, and for each individual file, we're gonna read it and we're gonna try to split it. Let's see what this pipe gonna look like. I'm gonna comment this function out just to see the output of the splitting. It says ffmpeg has no attribute input. Oh, I have to use ffmpeg Python, which integrate that into Python. Pipe install requirement. Now it should be fixed. There we go. The format of the output is like this. It says silence start from this time, silence end at this time, and this would be the duration, which is difference between these two numbers. The next silence is like this. It starts from this number until this number, and it's 9 seconds. So this is the format of the pipe output. Now we have to parse this string and extract these numbers. Let's copy it and bring it here so that we know what we need to do. I'm gonna import the regex finder library in Python. I'm gonna be looking for this string, then a number, then this string, and then another number. And you will group them together to make sure we're getting them both. And let's log every duration, see if it works. Can't unpack non-iterable non-time object. Before grouping them, I have to make sure that it actually exists, because in some audio file, we might not find any match. Very well. We know from this file, there's a silent starting from this, and it will end at this. So we have to now eliminate and delete them. It would be better if this would be a list, because we want to keep the context untagged. If you remember, we want to make sure all the segment from one file, they're all going to be together. Gonna import data classes. We're gonna call it audio chunk, and it should have the channel ID. Maybe create a separate file, call it models, just to keep things organized. We're gonna keep the conversation part in this object. I'm gonna call it start time, start at 0, and the cut time should be the end minus duration, right? And we also wanna have minimum segment length. We're gonna keep it at 5 seconds for now. Again, it's one of those parameters that we're gonna play with, but 5 seconds is good. Then if we found a segment that's more than 5 seconds, we need to update our data type. We're gonna have a path, channel ID, start at, and end at. It's going to have the start and end. We have a bunch of audio segments. It is much more clean. And you can see here that this individual file have 2 segments that has a valuable audio, and these files, they have nothing. They're completely empty. You can see. One last thing is here I said reader.wait. I ran it in async way, but then I waited here, so it's not actually async because we're waiting for it, right? I should probably use yield to return the result as soon as possible, but because our audio file is so small, I think we can ignore that. And for now, I'm just gonna wait and return the result without doing anything crazy. But If it turns out to be slow, we can convert this to yield if it's slow. Okay, right now we have a link that we can listen to, and we can understand the silence in that file, split it out. Now we have a bunch of segment here that we need to transcribe. We already have the function for transcribing using Whisper. I'm gonna copy it and bring it here. What it does is very simple. It just loads the model, go through all the audio files, and try to transcribe them. And if it finds any result, it's gonna write it into a file. Pretty simple. And at the end, it's going to delete that audio file. The change that we need to make here is we don't want to transcribe the whole file, rather just the segment that we found here, right? So for each file, we have audio chunks. And here, when we say transcribe this audio file, I'm going to trim the audio file. I'm gonna go through all the segments, and I'm gonna use ffmpeg and give that file and say, you have to trim the file from here to here and then just save it here. Pretty simple and straightforward. And for each section, I want you to transcribe it. I would love to add half a second or even 1 second before and after the trimming section. Okay? So I'm gonna say safety. I'm gonna say 1 second so I can read the meta file, the metadata of that file, and get the format and duration. It should give me the full duration, right? So I'm just adding a padding safety before the start time and another padding safety after at the end. And I'm also checking that it should be around the file itself. Let's create another folder for, I'm gonna call it trimmed audio. Just gonna make sure everything is working as we expect. Let's run that again. Oh, the duration, I have to convert that to float. There we go.
Emergency service Adam 2. Unconfirmed ED package comprised of the 19th precinct, Madison and East 3 Street. Unconfirmed. Emergency service Adam 5.
Seems like it's working very well. This file name is a little bit messy. I wanna convert that to int, just make it more clean. We have all the segments and all the transcription for each segment, which looks good. No weapon involved. Second floor, like something's happening, right? So what do we have so far? We've downloaded all the audio file, then we trim them down, and we only have this talking sections. You can see it right here. And then we transcribe each part using Whisper. So we have this whole process coded. Now it's time to make this faster and more efficient. We can convert this whole thing into 2 different processes. The first process is just listening to those links and download those audio files into files. So that could be the first process, and the second process could be trimming down each file and then transcribing it, this whole thing. If we can do that, we can have one function that keep downloading each file, and we can have another function that trim out silence and then transcribe the talking point. So we're gonna have 2 functions, and we can scale them differently if we need. First, I'm gonna separate this function and make sure it's working correctly and run it in a separate thread or process. Then I'm gonna do this second part and try to optimize it. So I'm gonna add more link that we can listen to. The base URL would be like this, and I'm gonna add that channel ID to the end. Chunk second, let it be 60 for now. I'm gonna use multi-processing, and because we have 4 channel, I'm gonna use a pool of 4. Let's test this part and see. They are running in parallel, and each minute we have 4 file being added. So this first part is done. One mistake that we made here, if I do it like this, if I create a map of processes, the problem would be it will stuck here and doesn't run it in background. So what I need to do is to set the daemon to true. And when you set the daemon to true, that means you can run independently from the main code. So I can change this code and say, create a process, set the daemon to true, and then simply start it. I can have a list of process that in the end of the code, I can say, wait for all the processes to finish. And I'm gonna put it on try catch just to make sure if I press Control C, the script actually stop and terminate all the processes, right? Instead of saving all these chunks to separate file, we can just trim the file and process it directly to Whisper without writing to any file. So I'm gonna delete this and I'm gonna say read the file, then try to trim the file from start to finish. I don't care about the file name, no stdin, and I'm gonna try to capture any error. I'm gonna use NumPy to create an array from that audio data. I'm gonna pass it to Whisper. A given NumPy array is not writable. I had to add this to our NumPy to make sure it's editable, and essentially I have to flat that array so the Whisper can go through it and read from it. Now we have the same transcription here, which means our trimming works and we're not writing to file anymore. We have all the transcriptions here. So let's run some timer and see how fast we're transcribing each file. We have about 20 audio files that each one is a 1-minute audio. I'm gonna comment this part and only focus on the transcription. Start time equals end time equals to. By the way, I'm not using any GPU. It's been purely run on CPU. So we can make this much faster if we migrate to GPU. As you can see, each individual file is taking a different time because we are removing any silence in the file. So some file and all of them are 1 minute's audio file, right? But you can see it takes 20 seconds, it takes 12 seconds, and sometimes even 8 seconds because we're deleting every silence in that file. 2 seconds, 5 seconds, 3 seconds. So it only take 2 seconds to transcribe a 1-minute audio, or it only taking 5 seconds to transcribe a 1-minute video because we're removing any silence in those audio files. There are some cases that a lot of conversation is going on in one particular 1-minute cut. You can see here it's taking 30 seconds to transcribe a 1-minute audio file. But keep in mind that I'm doing this purely on CPU. I'm not using any GPU whatsoever. For the next step, I'm gonna copy this code and don't change anything. Just copy this code and run it on GPU and see how faster it goes. I'm gonna use Google Cloud. I'm gonna copy paste everything we have here, pipe install. I'm gonna upload. I upload all the audio file we have, and you can see here the output on the GPU is much faster. 7 seconds, 4 seconds, 1 second, 7, 3. The longest we got is 15, but we got a bunch of 2, 3, 5, 1, 0, less than 1, not actually 0, but less than 1. Let's add even more file. I've uploaded about 140 audio files. that each one is a 1 minute audio file. I'm gonna change our log so that we can see the sum of the all transcription at once. Let's see how fast it can transcribe all this 140 audio file, which is 140 minutes. So that's 140 file, which is 140 minutes, which is around 2 hours, 2.5 hours, something like that. And we transcribe that in only 400 seconds, which is a little bit higher than 6 minutes, right? So 2 hours in just 6 minutes. That's how fast this transcription is. And it's using only 1.7 gigs of RAM, which is pretty low. We can definitely do some changes to use more GPU, but for 1.7 gigs of GPU, that's pretty good. Maybe they should integrate this feature into the Whisper and it will trim the file down with by default. But anyway, that's just one improvement that I did upon Whisper. I'm gonna put the code on GitHub so you can see, and maybe you can even improve it even more. In the next video, I'm gonna create one page and maybe just add the map and shows all the file that we're downloading and all the transcription in real time, and we can add much more audio files, maybe 100 audio files. Now, if you're wondering what are these audio files and what are these channel IDs, why we're using timestamp, things like that, I'm gonna put the previous video right here so you can check it out. In that video, I explain exactly what we're doing and what we're building. If you enjoyed the theme of this video, go check out that video. I hope you enjoyed watching this one, and I will see you in the next video.